Alright, we're going to continue to work the extra kinetics problems, but in these particular problems we're going to work the reaction mechanisms. Now remember, reaction mechanisms are the actual steps involved in a reaction. And sometimes they're very similar to the overall equation, sometimes they're not, so it often has to be assessed. Now, this is like doing math and taking equation 1 plus equation 2 and summing them to get the overall or total equation. Now, when you do this, you're going to eliminate anything that appears on both sides. So, for example, as we go across, wait, that appears on both sides. This species here appears on both sides. Oh, wait, we have one water as a product, but only one as a reactant. So we would leave the water, but move the change the coefficient to 2. So then once we've eliminated anything that's changing or appears on both sides, we write what's left. So we're going to start with the carbon double bond oxygen OCH3 plus 1 water yields CH3 C double bond O OH plus HOCH3. Okay, so this will be the equation for the overall reaction. Since I've written it once, I'm not going to rewrite it there. Now, when I write the rate law is the slow step. The slow step determines how fast or how slow the reaction is going to go. So, we identify our slow step, and since it's an elementary step, that means everything that's reacting appears in it. So what we're going to have is the rate is equal to K times the reactant species, which in the slow step we have CH3 COH plus OCH3 raised to the first, because there's only one of them, and water raised to the second, because there is a coefficient here. Now, we eliminated when we were totaling it to get the overall, but with the elementary step, we have to work with whatever it is that we have. Okay? So, we're done with our rate law. Now, catalyst, remember, speeds up the reaction without being consumed. Okay? So, oftentimes what that means is that it appears in the first one, first step reactant, and then is reproduced in the last step. So, consumed. Sorry, can't spell. Alright, so if we look back, remember we said that H3O plus is in the reactant first step and it's appearing in the product last step. So that means it's being used up without being consumed. So we use it and then we regenerate it. So yes, there is a catalyst and it is H3O plus. Now the next one says identify all intermediates. Intermediates are generated and used up in the reaction. So you don't see them in the overall equation for the overall reaction. So again, whether they appear here is not important. What is important is we cancel them out. Now, we can't use this one because it's the catalyst, but this one is generated and then consumed, and this one is generated and then one of them is consumed. So we have two intermediates. One is the CH3 COH OCH3 plus, and we have a water. Now, notice that the intermediates do not appear in the overall reaction, but they are in the rate law. This is not uncommon in a reaction mechanism. So this is problem number 8. Let's look at problem number 9. It's the same type of problem, but very different. The following mechanism is proposed. Here they're giving you the overall reaction. So they've already done what we did before. We have the 3 steps. which of these is the rate determining step? Well, the slow step is always the rate determining step, so it's step 2. What is its molecularity? Well, remember, molecularity has to do with how many molecules are reacting in the step. So if we look at it, we've got one molecule of this and one molecule of that. So 1 plus 1 is 2, so it's bimolecular. Remember, if it was 1, it'd be unimolecular, and if it's 3, it's termolecular. What is the role of N2Cl in the mechanism? Okay, well, I don't see it in the overall reaction, so let's look at where it is here. Oh, look, it's being generated here and then being consumed here. That means it is an intermediate because it is generated and consumed within the reaction. Now, what is the role of hydroxide in the mechanism? So it's not here until this initial step, but it's used up here. But if we look at the overall, we see it as both a reactant and a product. So it's used within the reaction mechanism, but it's not where you would expect it. But we see it in the overall. Anything that appears on both sides of the overall reaction, that's one way to write a catalyst. You can also have written it just right up here on the arrow. Then again, what is the rate expression for the rate determining elementary reaction? Again, we're back to our slow step, which means rate is equal to K times NH2Cl times NH3. And we have now identified all the pieces part in a second mechanism.